Good day, Evan Snellman here for our third video in our series on sequences and series. And what we're going to look at today is some examples. On the screen here, I have all the formulae that you need to know, okay, in red and green, okay, knowing that the two red ones are for arithmetic and the green ones are for geometric. The T formulae are for sequences and the S formulae are for series, okay. Please notice that the blue formulae are not given to you, but they are useful ones to know. Okay, A equals T1, D is the common difference, R is the common ratio, and S of n, well, if it is running total, it's simply the previous total plus the new term. Okay, so we're going to look at now is some exam examples. Okay, we are told keywords that this thing is arithmetic. Okay, and we are told that it is a sequence. Okay, so we're told that it's arithmetic. And again, nicely, they're asking us to show that P equals 11. So if we get the answer of P equaling 11, we should be quite happy with ourselves. Okay, so because we know that this is arithmetic, we know that the difference between the terms is going to be a constant. So T2 minus T1 equals T3 minus T2. Okay, so P plus 6 minus 2P plus 3 must equal P minus 2 minus P plus 6. Collect all this will be minus P plus 3 equals no P's. I'm getting an answer here of minus 8. So I'm getting minus P equals minus 11. P does equal 11. And I know that those 2 marks are probably secure. Okay, please, again, not only am I trying to teach you the content of the mathematics, but there is also a definite value to knowing that you're doing well as you progress through the paper. Calculate the smallest value for which this thing has a term value less than 55, okay? So again, they're talking about T of n, okay? So therefore, 3.1.2, what I need to know is what Tn equals. In this case, we can realize that, well, hold on, if P equals 11, then this pattern is actually going to be 22 plus 3, which is 25, P plus 6, which is 17, and P minus 2, which is 9. Now, hopefully, if quick check would confirm that this is in fact arithmetic because we are minusing 8 and we are minusing 8. So it is in fact arithmetic. What this gives us is that, therefore, A is 25, and the realization from that was that, therefore, D equaled minus 8. So we know that Tn is going to be 25 plus n minus 1 times minus 8. And we want that to be less than minus 55. So we do our work. N minus 1 times minus 8 would be less than, we take the 25 across. Okay, and we subtract 25 from both sides. And we only get minus 80. We're going to divide by minus 8. So again, they've been quite crafty here. They've forced our hand. So we know that therefore the sign changes. Okay, the inequality sign changes because we divided by a negative, and therefore n will be greater than 11. Okay, and so again, they put some other maths from another topic here, in this case, a linear inequality, and then mix it in with the work. Okay, not too difficult. Okay, and I think that's why so many people like sequences and series, because there are quite often some easy marks to be got in this topic. Again, read the important stuff here. They tell us that this thing is geometric. Okay, so again, we know therefore that therefore 2.1, that therefore the R value is T2 over T1 is the same as T3 over T2, which is the same as saying that T2 squared equals T1 times T3. So I'm going to choose to use that latter version. It just is less needing of fractions. Okay. So as a result, B squared equals minus a quarter times by minus 1. So b squared equals 1/4. So b equals plus or minus a half. Okay. The good news, which kind of makes me feel a bit better about myself, is they tell us that they want us to continue with b equaling a half. Okay, so we are now being asked to find the 19th term of the sequence. So 2.2 term 19 will equal a times r to the power of 18. We know that a is a quarter, is minus a quarter. They've told us that b equals, so if b equals a half, we are dealing with minus a quarter, a half minus 1, which hopefully we realize therefore that r is equal to minus 2. So we go back to our formula here. This is times minus 2 to the 18. Now, we don't need to evaluate this, but we can if we wanted to. Okay, so minus 2 to the power of 18 is some really, really big value. Divided by 4, the answer here would be minus 65,536. Okay, so again, question 2.2, just a simple substitution, but we needed to find the r value, so there was a bold on from question 2.1. For 2.3, write the sum of the first 20 terms in sigma notation. Now we've got to be careful. They have thrown a curveball into this question that if we didn't read carefully, we would miss. And they have said they wanted the positive terms. Okay? So what we need to do now is we need to think about what that means for our pattern. Okay? And so what we have here is a pattern that no longer goes, okay? So we no longer insert in that pattern over here, okay? Because it contains negative terms. What I now want is the sequence that goes a half, 2, 8, 32, etc. Okay? The one that has only got positive terms. And so since we are actually dealing with a sigma notation, what they're actually asking us to do is to actually consider what happens if we were to add all these terms. So what we have here is sigma, okay, from n equals 1 to 50, because I said the first 50 terms of the term type. Okay, and the type of term here, or let's rewrite this pattern as a term. So what we hopefully get is that a equals a half and r equals 4. So we have a half times 4 to the power of n minus 1. Okay, now the final question is an interesting one. Okay, is this series convergent or not? And that is simply a piece of knowledge. And they said that if r was between 1 and minus 1, this thing would be convergent. Okay. However, what we have here is a r value of 4. And so for 2.4, our answer would be no, it is divergent. And if there wasn't a reason, it is because r is greater than 1. Okay, our reason here would be because r is greater than 1. Okay, so again, some interesting work here, but not the most challenging at this point in time. Now we have a practical example, a case of a tree growing, okay? And we do know this, trees grow, but as they grow, the amount that they grow each year is less and less, and they do tend to peak out at a particular height and then apparently stop growing, even though we know that trees never do actually stop growing. Okay, so when he bought it, he measured its heights, okay? And so he knows that the height here was the change in height, the increase in height was 100, then 70, then 49. Okay? He noticed that this pattern was geometric, during which year would the height increase by approximately 11.6. Okay, so what we are being asked to do is to realize that therefore 100 70, 49, and eventually at some stage, 11,76 millimeters will be part of this pattern. Okay, and we've got term 1, term 2, term 3, and we've been asked to find which term that one is. Again, okay, we know that R equals term 2 divided by term 1. So this case would be 70 divided by 100, which is 0.7. So again, we can see that here. We have times by 0.7. We have times by 0.7. Okay. Now we could simply do this on a calculator and keep track of how many times we have tapped the calculator. But what I'm going to do is have a look at this in terms of algebra. So let's have a look. We know that Tn, sorry, wrong color. Okay, we know that Tn is going to equal AR to the n minus 1. So we know that 11.76 is going to equal 100 times 0.7 to the power of n minus 1. So we divide through by 100. So 0.1176, do not round off, equals 0.7 to the power of n minus 1. We are going to use logs. So log of 0.7 of 0.1176 would equal n minus 1. So let's try that on the calculator. Log of 0.7, let's go here quickly. 0.7 of 0.1176, and we get an answer of 6. Okay, so as a result, okay, n minus 1 equals 6, so n equals 7. Okay, so during the 7th year. Okay. You know that some areas are quite fussy if you don't actually answer the question during which year. So actually answer the 7th year. Okay. He plots a graph to represent the height of the tree. Okay. So now we're not talking about we are not talking about the change in height. We're actually talking about the height. Okay. So we know that if we were to consider what this graph would look like, okay, we know that it grows from a seed. At the end of the first year, it is sitting at 100. At the end of the second year, it is actually sitting at 170. Okay, and at the end of the third year, it is sitting at 219. Okay, so this graph, if we were to plot it, they're not asking us to plot it. Okay, they're not asking us to plot it, but this graph would do something along the lines of flattening out. Okay, now what we need to realize is that this value here is term 1. This value here is term 1 plus term 2. This value here is term 1 plus term 2 plus term 3. In effect, what we need to realize is that this is S1, this is S2, and that this is S3. So this graph is actually the graph of S, okay? So as a result, what we are hoping to find is, okay, 3.2, h of n would equal a times r to the n minus 1 over r minus 1. Okay, or we could do the reverse of that, but we don't want it with variables, we want it with the values. So what we're going to do is we're going to come back in here and realize that we can substitute a with, well, the a value was 100, and the r value was simply 0.7. Okay, so we're going to come in here again with the eraser. I'm going to with the eraser and erase the r values because we worked out that the r value was 0.7. Okay, and there is our formula for that graph. Okay, so interestingly, okay, that is our formula. What height will the tree reach eventually? Now, because this r value is between 1 and minus 1, okay, because it is in between 1 and -1, it will converge. Okay, so sum to infinity would equal a over 1 minus r. So now 3.3 is not massively complicated in this case again. It's just a case of making sense of all the writing. Okay, this tree's maximum height will be the sum to infinity of all the increases of the growth from each year. And so it's going to be 100 over 1 minus 0.7. So it's going to be 100, okay, divided by brackets 1 minus 0.7, which is 100 over 3, so 1,000 over 3. Okay, so hold on, where's my pen gone to? There. So it'll be 1,000 over 3, or 333.3 millimeters. Okay, and again, because this context is a real-life context, please don't forget to give your units. Okay, so what we saw here was a very different question from the previous one, where here it was quite austere and quite boring. They just simply gave us some formulae. Okay, here they've given us a context and they've made it into a real-life problem. Okay, here we have another fairly austere question, but what interested me and why I chose this example was this interesting fraction at the bottom. Okay, so given find R, the common ratio, again, nice and friendly, only worth 1 mark. So that would be -8, sorry, wrong color. Okay, so that would be R equals -18 over 36 equals -1/2. And already thoughts in my head around the fact that this thing is therefore converging. And so surprise, surprise, in 2.2.3, they're asking about sum to infinity. Calculate n if n is that value. Well, again, we know that Tn will equal a, so that's 36, times -1/2 to the power of n minus 1, and that equals 9 over 4096. So we divide by 36, so -1/2 power of n minus 1, so 9 divided by 4096, okay, divided by 36 equals a crazy number, okay, 1 over 16384, okay, which is a power of 2. So we can take log 0.5 of that answer. And we get therefore that n minus 1 equals 14, and therefore n equals 15. Okay, calculate the sum to infinity. Again, not the world's worst. We know that the sum to infinity will equal a over 1 minus r. So it will equal the first term, which is 36, over 1 minus -1/2. So that is equal to 36 divided by, which is in this case 24. Okay, so the sum to infinity here is 24. Calculate the value of term 1 plus term 3 plus term 5, etc., up to term 499, divided by term 2, term 4, up to term 500. Okay, so as I said, this was the one that interested me and why I chose to do this example. Okay, so let's have a look here. What do we have? Term 1 would be, so again, I'm going to choose to just create some space here to look at this problem. Okay, term 1. So let's just look at this fraction as a bigger fraction. Let's see if we can make sense of it. Okay, there must be some type of cleverness to it. So 36 was the first term. The second term was minus, again, I've just lost track of it, was -18. Okay. The third term was 9. The fourth term would have been -9 over 2. then we would have had plus 9 over 4, and then minus 9 over 8, okay, etc. Okay, so again, what I'm seeing here is that effectively, and it goes down to term 499 and term 400 and term 500. That's not overly important right now. What I am seeing is that there's a link between these two and these two and these two. Okay? Firstly, the top ones are all positive, and secondly, the bottom ones are all negative. So what I'm going to do with is I'm going to deal with that issue first. So this is going to be 36 plus 9 plus 9 over 4 plus whatever up to term 499, all divided by effectively minus in front 18 plus 9 over 2 plus 9 over 8 plus etc. Okay? And so what I have here is a situation where, I can see what I need to do. I'm going to have minus 2 times 18 plus 9 over 2 plus 9 over 8 plus term 500 all over 18 plus 9 over 2 plus 9 over 8 plus. Now, the worst part about this is realizing that actually what I've got here is term 500 over term 500. Okay? But by dividing by 2, I've shifted each one of these one across, and so that term 499 becomes term 500. Okay? Again, we can see that that bracket at the top, and by putting brackets on the bottom, is a little bit easier to see, but those are the same. So therefore, that whole bracket, that whole factor will cancel with that whole factor, and my answer would be minus 2. Okay, and so that's quite a crafty question. Okay, so 2.2.4 was worth a look, and the unusual type of question led to a slightly unusual technique where we needed to factorize, and we got an answer here of minus 2. Kind of crazy that this all simplified down to such a neat answer. Okay. A last one to look at quickly. They are now going back to quadratics. And again, I just want to look at this again to remind you that although we have had to spend a lot of time focusing on arithmetic and geometric, please don't forget that quadratic sequences, there is no such thing in a school syllabus as a quadratic series. Okay, that's the good news. But a quadratic sequence is still possible. So we've got term 11, okay, and term n and term n minus, and a formula that links consecutive terms. So therefore, we can work out, okay, that term 12 minus term 11 would equal 3 times 12 minus 4 if I made this thing equal to, if I made, okay, what I'm doing here is I'm making n equal to 12. Okay, if I do that, I get term 12 minus term 11 equals this. But we know that term 11, okay, was 125. So we know that term 11 is 125. Therefore, term 12 minus 125, okay, equals 36 minus 4, so that would be 32. So we know that, therefore, term 12 equals plus 125 would be 157, okay? So what I'm looking for here is a couple of terms so that hopefully I can make sense of this. So we know that term 11 is 125. We know that term 12 is 157. Okay, so at this point in time, we know that therefore the first difference is going to be 32. Okay, we can work out the second difference here shortly if we had another first difference. So let's look at term 13. Term 13 minus term 12 equals 3 times 13 minus 4. Okay, so therefore term 13 minus 157 equals 35. So therefore term 13 equals, add 35 to this, that's 162, 192. Okay, so we know that this term is 192. Okay, so what we do now know is that this value is 35. Okay, which tells us that our second difference is 3. Okay, now that is important because they've told us that this thing is quadratic. Okay, so what we're going to get to quite quickly, hopefully, is realizing that therefore a equals 3, the a equals 3/2. But again, this is why we changed the notation. This is not the a value of the first term of the sequence. This is the a value of the quadratic formula, Tn equals an squared plus bn plus c. Okay? This a here does not equal the first term. Okay? And that's partly why they're doing this. Okay? They're trying to see if you are aware of the notational change where a used to be the coefficient of the n squared, and now a is the first term. So I'm going to plug in what I do know. Okay, I do now know that Tn equals 3/2 times n squared plus bn plus c. Again, I'm going to go back to what they told me to start with, which was that Tn equaled 125. So T of 11 equals 3/2 times 121 plus 11b plus c. Okay, I'm going to go back to the thing that I've discovered, which was this one here. Okay, so as a result, T12 equals 3/2 times 144 plus 12b plus c. If I was to take those two formulae that I've now just worked out in over here, okay, and I was to do simultaneous equations with them, okay, what I would get is, sorry, I needed my values here. I've been a bit remiss. Okay, this one equaled 125. This one equaled 157. Okay, and if I was to subtract, I would get minus 32 equals, again, just quickly have a look here. Okay, so 3 divided by 2 times 121 minus 3 divided by 2 times 144 equals minus 69/2. I'd have only 1b and the c's would fall away. So if we times through by 2, we'd have minus 64 equals minus 69 minus 2b. We'd have 5 equals 2b. And as a result, 5/2 equals 5/2 equals b. Okay, we could go through and now find c. Okay, so we now know that, again, we do the same trick. If the trick works, we keep doing the same trick. Okay, so now we know that Tn equals 3/2 n squared plus 5/2 n plus c. Let's sub in term 11. Term 11 equaled 125 equals 3/2 times 121 plus 5/2 times 11 plus c. So 125 minus 3 divided by 2 times 121 minus 5 divided by 2 times 11 equals c equals minus 84. And so now we have our formula. Okay, so now we know that Tn equals minus 3/2 n squared plus 5/2 n minus 84. So term 1, which is what we would normally call A, would be minus 3/2 plus 5/2 minus 84. So minus 84. So we're going to get an answer of minus 83. The first term is minus 83. Okay, so I hope you've seen that the questions in this topic are quite varied, but actually, if we keep track of which formula we are using, okay, we are fine. Just please don't forget that the formulae for quadratic patterns are not given to you, and please remember that there are no such things as quadratic series in the school syllabus. All the best for you going forwards. Cheers.